Hello, Glowbusters. Yes, of course they're serious. You do? You have? No kidding. Uh-huh. Oh, they'll cure your globitis this week. Thank you. We got one!
Ladies and gentlemen,
it's the Glowbusters.
What are you supposed to be, some kind of a cosmonaut?
No, we're exterminators.
And now, here's your host.
And welcome everybody to Glowbusters, Electricity's Role in Earth Function. I am your host, Bob Xanadude60, and here we are back on another Wednesday show. And we have some kind of interesting things to talk about today. We've been kind of kicking around some different ideas for, models, of course, how the flat Earth model might actually work, because, me personally, I don't like it when we get trolled and say, oh, you guys don't even have a model to show. In my opinion, I don't see any reason why we can't have a model. As far as the flat Earth map, we can pretty much explain the sun's function and how that works. And also we can show you, quite easily how the globers are lying to everybody, especially on the equinoxes about the sun rising due east and setting due west and what that actually is, and how they kind of, mislead us into believing that something that just isn't true. But that's beside the point. Other than that, I think we have a lot of things that we can explain, especially some of the biggest things that we get are, well, how can you have two counter-rotating sets of stars in the north and the south? Actually, there's a few explanations that can explain that. I, of course, have my preference on one, and there are other people that have other ideas, but both are definitely viable. And, there's just no reason to not be able to put something together like this. So we are going to start by looking at some of the basics, of course, and that is electricity's role and, of course, magnetism's role in good old plain Earth. And we have several people with us today that are going to be kind of helping me out talk about that. As you all know, Jeran is on vacation. He's going to be taking out for about another 3 weeks. And it's not that he's actually on vacation. He's actually just trying to get caught up on all of his crypto consultations and, all that good stuff. So he's going to be gone for a few weeks, but that's okay. We will manage. And, we'll do the Sunday shows as normal, so everything is going to be just fine. So I want to tell you guys a story that's kind of crazy. And, one of the things that I get is some really interesting trolling. And every once in a while, I will, get a comment from somebody, and I will think that they're actually being, straight up and they're being honest about their inquiry, right? So if I don't think so, I'll just delete it, because I don't have time for trolls. I don't have time for nonsense. And everybody just wants to, waste your time basically, or they think that they are entitled, to my time when, frankly, when you have, 60,000 plus subscribers, it's really difficult to do that. So, I do the best I can, but, I cannot be sitting here dedicating personal explanations to everybody, that just comes along and wants one. So I try and do those in my show. So today I got a comment that was talking about, a comment that I had made. I think I was on Sunday, or actually Monday's show, about, one of the things about the downward accelerative force is that, that relative density disequilibrium cannot explain and does not explain, is the fact that when you drop an object, not only does it go down, right, which is interesting in itself that it picks that direction, but it also accelerates, okay? So that's something that relative density disequilibrium cannot explain at all. Why does that object accelerate? That's, it takes obviously quite a bit of force or energy to not only, overcome the inertia of, say, a 200-pound man, for example, and if he jumps out of an airplane or a big balloon or something like that, he's going to accelerate. When I was in the Air Force, I did some skydiving, which was one of the craziest fun things I ever did in my life. And, you come down and your heart is in your throat and you just think, oh my God, I got to do it again. I got to do it again. But as you're falling down, you think your life is going to end, of course. But one thing that you do acutely become aware of is that once you step out of that airplane, you start falling and you start picking up speed big time. And of course, there are, various things that you can do to accelerate your speed. And that is, to basically change your body's orientation and position so that you cut through the wind like a knife, or you can spread eagle out and you can cause a big wind resistance, which will drop your terminal velocity, right? Okay, so getting back to the story. So some guy left a comment and he said, well, can you give me an example of something that goes into supersonic speed when it's dropped out, or it's basically dropped. And so I thought, well, this will be an easy one. So what I did was I showed him the statistics on the Felix Baumgartner jump, right? And a lot of people think, oh, that didn't happen. And, there's videos out there that are showing that it, supposedly wasn't real. But what a lot of people don't understand about those videos, even though they're showing that there's different paint jobs and different lettering on the outside, there were test jumps that actually did take place beforehand, right? So anyway, whether or not you believe that was real or not, I used that as an example. And I said, well, okay, so when Felix Baumgartner jumped out of the balloon, he accelerated to, it was close to 800 miles an hour. It was over 700 miles an hour, something like that. Anyway, it went beyond the speed of sound. He actually went supersonic. And they were supposedly, not only did he have the instrumentation in his suit that monitored that, but he also was being tracked by radar from the ground. Okay, so cool. I figured that'd be an easy one to accept. But then this guy comes back and says, oh, well, that was a lie, and that, that never happened or anything like that. And I'm just like, well, I don't understand your point. I mean, are you questioning that things accelerate when they get dropped or go down? And he never would elaborate on exactly what he's thinking about. So he's just sitting there telling me, that I'm being dishonest and, lying about this stuff. And it's like, great, whatever. Maybe I should have used a different example besides Felix Baumgartner, but whatever. The idea is that I was trying to demonstrate that when objects do not have something to slow their fall, to create a resistance, to create that thing that we call terminal velocity, then they will slow to about 120 miles per hour in the Earth's atmosphere, okay? Now, it can vary plus or minus from that, but that's generally a good figure. But it just blows me away that, somebody would doubt that. And again, like I said, even if he didn't jump and it was a hoax, which I don't think it was because I don't see any reason for it to be a hoax, but even if it was, it doesn't negate the fact that things accelerate. And if you take away the atmosphere or to put something in a vacuum, it's going to keep accelerating to what? An unknown speed. I mean, how fast will it actually go? The gravitational constant tells us that it's 9.8 meters per second squared, but how far can we really test that, right? We don't have any vacuum facility that is, capable of doing a test like that or anything like that. So, you just have to kind of use your head and understand that if there's nothing to slow it down, then as far as we know, things just continue to accelerate. Now, I seriously doubt that, they're going to accelerate to the speed of light or anything like that. But then again, we don't really know. But, now NASA would tell us, if you look at NASA and if they're orbiting craft, which are going around the Earth at 17,500 miles an hour, well, that would kind of tell me that since they've got to counteract that falling rate, because they're literally falling around the Earth, right, with a forward velocity, for that specific distance at 240 miles up, that, supposedly the quote unquote terminal velocity at that altitude would be 17,500 miles an hour. Of course, we all know that's bullshit, right? But it's just something to think about, right? But the whole point is, it is amazing that I would actually get trolled by somebody, wanting me to do tests to prove that things actually accelerate as they go down. It's like, oh my God. So anyway, just an interesting story I thought you guys might want to hear, because, this is the kind of nonsense I have to deal with, and a lot of the creators have to deal with, just completely non sequitur and irrelevant questions. And people just, they want to think, they have this gotcha question, like they're going to get you, and, I'm not purporting to have all the answers, but, I think I have enough of them that I can pretty much hold my own. But I really do get irritated when people, waste my time with stuff like that. It's just really annoying. But anyway. So anyway, guys, enough of that. Let's go ahead and move on and introduce the panel for today before we get to some of the interesting things we have to talk about. Let's see. Gosh, who do we have here? Well, first up, let's introduce Mr. Good Times for All, or Zachary Zabala, if you prefer. Zach, how you doing, sir?
Hey, Bobo. Doing real good, man. Thanks for having me.
Awesome. Glad you are here, sir. And also, we have with us LC King, otherwise known as Lucas King. And how are you doing today, Lucas?
I'm doing well. Thanks, Bob. Yep. Glad to be here.
Awesome. Yeah, we're finally going to get a chance to talk about some electric earth stuff today. Well, I mean, it's not like we don't, but this is an area where it really has your attention, and well, it does all of us, but there's some specific configurations and models that you are very much developing, and I think you're doing a good job with it. I don't know if I agree with all of it, but I think that even the parts that may not fit into each other, we can certainly work it out, and it's interesting to hear other ideas on stuff like this. But for the most part, I think you're right on the money, especially with the way that the Earth is generating electricity. And it's a kind of galvanic cell configuration. So that's very cool. So finally, we're getting to talk about that today.
Yeah, that sounds great, because I've spent a great deal of time looking at this sort of stuff, and it's it'd be good to present it to people and see what they think.
Yep, absolutely. I totally agree. And back with us again today, we also have Mr. John Savage. And how are you doing today, sir?
Oh, I'm doing very well, and a big hello from Prison Britain. Hi guys, and yeah, looking forward to this one. I've had me ear bent by Lucas for several weeks now, so yeah, it's good to get this out, definitely.
Prison Britain?
I know we don't want to talk too much about that, but is it really still pretty bad? I mean, things over here, I'm seeing things, I don't want to say the word normal, but when I go to the grocery store, there's barely anybody wearing a mask besides people that are working there. I think I saw 2 masks the other day, and I went into a couple different shops. I was running the lady next door around, and I saw like 2 masks out of everywhere we went. Yeah, restaurants are packed. It's nice.
It's hella depressing over here. I would say we're close to 100% masks. It doesn't seem to be getting any
Couple
better.
different shops. I was running the.
Whoops, sorry guys. I
But
freaked
yeah,
out, didn't I?
everything is the walls are closing in on us over here. I mentioned last week about pressure canning, and someone was saying, well, asking where I was, but we can't do anything. I found out today that they've, as of the 1st of May, they've banned bituminous coal, which I'm still staggered about. They're forcing us all to use their smokeless, chemical-ridden, those coal briquette things or whatever, rather than just the stuff you dig out the ground. So what I run my house on, basically. So yeah, banning coal, you name it. It's just, it's chronic over here.
Yeah, that's crazy. Well, yeah, speaking of that, one of the things that I do want to do today, and I hopefully this is okay with you guys, but after we get done with the electrical presentation, I am also streaming this show on DLive as well as Rockfin. Now, DLive and Rockfin, if DLive, if I get a strike for it on DLive, or if there is such a thing, or if they take any sort of punitive action, I don't really give a crap because I don't really use DLive that much. But after we complete the show today, I'm going to shut down the YouTube stream and then broadcast on Rockfin and DLive. And Rockfin, I do have set today, folks, for a free show. So you can actually go there and watch today's show on Rockfin for free. And, that will allow me to say some things that I think are kind of important that, I found out this week. And even though it's, not directly related to flat Earth, I can't really talk about it on YouTube. Of course, we all know why. And it's just something that I wanted to make a commentary about. So that will be coming up at the end of the stream. Won't take too long, but I feel it's kind of important and interesting also. So there you have it. This is kind of nice having the Rockfin platform to be able to do stuff like that as well. But yeah, pretty cool.
Yeah, being able to speak your mind freely it's a good feeling, isn't it?
It really is.
The crazy nonsense. Yeah, I'm glad you guys made the jump. It was needed.
Yep, absolutely. So
who the hell would have thought we'd be in this position speaking about things that you can't say on YouTube or whatever? I mean,
yeah,
crazy.
Especially in America.
In anywhere, yeah. Madness.
Yeah, it really is crazy. Sorry, I was just taking a sip of coffee there. Okay. All right. So, let me go ahead and, so Lucas shared a couple of videos, with us at the beginning. And I think what I want to do is I kind of want to, the one's only 2 minutes and then the other one is, just under 4 minutes, and I'll play them at, 1 1/4 speed. So, I kind of want to go through these two videos, just as kind of a primer, to start you guys off, and then we can kind of elaborate on it. And then, Lucas can also bring in, his model, and we can kind of expand on that. Does that sound good to everybody?
Yeah.
Yep. Sounds good.
Sure.
All righty then. All right. So let's do this one. How clouds follow the Earth's electrical heartbeat. And I thought this was kind of interesting. So let's go ahead and maximize that and give this a play. So here we go, guys.
One of the remarkable things about the atmosphere is that there's a current flowing all the way from the top of the atmosphere to the ground. And this is generated globally by thunderstorms, and the current flows around the entire planet. And here at Reading we have some sampling plates which allow us to collect that current and measure it. So from measurements made in the 1920s on a sailing ship called the Carnegie, it was found that this current varied over the day like this. No matter where you were on the planet, with a minimum at about 3 o'clock in the morning UT, and about 19 hours UT, there was a maximum. So if you think of that happening on all days, really this means that there's a sort of heartbeat of atmospheric electricity which is running through every day as a result of the Carnegie curve. So we're interested in whether this curve was actually present in clouds themselves. In other words, was there an effect of the current on the clouds through which they passed? And to do that, we need to go somewhere where there's very little in the way of other influences on the clouds. We went to the poles for that because in the northern hemisphere and the southern hemisphere, measurements are routinely made of the bases of clouds using lasers. They fire the light into the sky and measure how long it takes for the light to come back and therefore work out the height of the cloud. So we took the hourly measurements of cloud base height from these two sites and compared them with the Carnegie curve, and we found that there was a variation that was very similar. So this illustrates really for the first time that there are changes in the clouds which we can associate with the Carnegie curve variations and the electrical currents that are flowing.
All right, beautiful. So, that was kind of interesting because the Carnegie curve is, of course, you can't really mix that up with the Schumann resonance, right? Schumann resonance is something completely different. We'll kind of try and, put it into its place as we do this, but the Schumann resonance is typically like 7.83 hertz. And this is happening, where you're getting swings in voltage, basically, once in the morning and then once later in the afternoon, which is kind of interesting. So they didn't really get specific on exactly how much the voltage was. Do you have any information on that, Lucas, about how much of a variance there was, or just a variance?
No, it's just that video, but
I think it's around a 15% change at 7 p.m. UTC. It'll be 15% higher than the lull at 3 a.m. UTC.
Okay.
And there's people that have done a lot of research on this. It actually isn't. It's almost like it starts in the center, almost like a water droplet, and works its way out. It does it very quickly, but from like northern Africa to southern Africa, there is a slight variation in what time it happens. It's not all at once everywhere this goes up and raises down. It's more like it seems, from what I've researched, it could be the exact opposite. I didn't dig too deep into it, but it doesn't happen exactly at the same time everywhere. It kind of permeates in one spot and then resonates out from there. It does it very quickly, but covering really large distances, there is a slight variation on the exact time when it happens in the atmosphere above your head.
Oh, that makes sense. And, there's a lot of things that happen, almost like clockwork, right? When you on the Earth that are quite interesting, things like Yellowstone, right? And it has eruptions, every so many hours or minutes. I can't remember exactly what it is, but it's very, you can pretty much set your clock by it for the most part. And, so the Earth obviously is responding to and has its own, multiple either heartbeats or, I don't know if I'd call them all heartbeats, but definite cyclical patterns in the way that it functions, very much making it seem like it's almost alive, right? And, I don't know if it could be considered alive or anything like that, but, it does support a lot of life. And, without the environment that it provides for us, we certainly would not be able to function, that's for sure. And the electricity that is present in this atmosphere, I think, is absolutely, one of the things that we cannot live without. I think, honestly, if we were to ever actually remove somebody from this electrical field that we are kind of swimming in, it would be kind of like taking a fish out of water, right? Because that electricity is just as much our environment that we survive and function in as, the air we breathe and everything else. So that's, just kind of the way I look at it. But I've talked about this.
Jump in real quick, Bob?
Sure, go ahead.
I've been thinking about this a lot over the last, 6 months, just to myself, about the electric field. And if you actually remove something from it, I don't know if it would exist anymore. It's like the electric field is like the ether. It's that medium that everything needs to, structure itself in. If you're not within this, I don't know if matter would be able to even hold itself together without the forces that are created in here that are, doing all this stuff.
Well,
It's really, yeah, it's really been like pulling a thread in my brain saying, hey, there might be something to that. I don't know if matter can exist outside of the electric field. I don't know.
And we do see, I've seen some videos and things like that where they actually increase the electric field for, say, plants or animals, and they'll, change their structure themselves. So I think you're spot on there, Zach.
Yeah, I totally agree. And of course, when you're talking about that, then you almost get into a little bit of philosophy because, honestly, yeah, I agree completely. The electricity is part of it's a modality of the ether. And, speaking of the ether, guys, you guys have heard me talk about it for years now, literally, what the ether is and how reality is actually manifested out of it. And there are a lot of people that are completely under the delusion that the ether does not exist. Well, why do they think that? They think it because Albert Einstein eliminated it mathematically, even though he was a big believer in it, 100%. But because of the fact, there were some experiments that were run that kind of annihilated the idea that the Earth was in motion. He had to come up with something, and that was essentially to eliminate the luminiferous ether, which is something that, all of science agreed on for hundreds of years. And, it's definitely there. I mean, we can measure it. We can analyze its behavior. We can, do a lot of things with it, honestly. And of course, that was, in fact, the very thing that we were detecting with the fiber optic gyro, in my opinion. But, if you think that science has completely given up on the ether, you need to think again, because there are so many papers out there that are written well after Einstein declared the ether non-existent. I mean, right up to 2021, right up to this year, people are still coming up with papers on the ether and how it interacts with electrical and magnetic fields. They're not going to give it up. The trolls will have you believe that it doesn't exist, but it does. It most certainly does. And when you start understanding, how some of these things actually work, like magnetism and gravity, then you start understanding really the necessity and the role that ether plays in it. So I just kind of want to point that out. So
well, it's not just ether, is it? Oh, it's not just ether, is it? There's plenty of academics out there that will tell you Einstein was full of nonsense, start to finish, basically, and they're becoming more vocal too.
Yes. Go ahead, Zach.
Yeah, and it's not like today's physicists that are actually, playing with particle accelerators and this and that, which I would consider more of a physicist than an astrophysicist. At least they're actually, manipulating something and observing it. But they still renamed the ether the Higgs field back in the 80s. It's not like they did away with it and they just gave it a new title. So they still need it, and it just has a new name, but they need it for all of their stuff to work.
Similar to polio, then.
Yeah, something like that. Yeah, they call it the quantum field or, something like that. But believe me, there are a lot of mainstream people like this gentleman right here who we're going to be talking about a little bit later. Here we have a paper that was just written in 2020, right? I mean, these things are all over the place. And there's just no doubt about it that it actually exists. So, but anyway, we're kind of getting sidetracked here. So, last thing I will say about, the last video that we watched, of course, is that not only is there this electrical field that's going on, in our atmosphere, but, it's been measured at generally at about 100 volts per meter. Okay. And this comes from a guy named Richard Feynman, who was himself, I don't think he really understood much about it, regardless of the fact he was, so highly thought of in the science community. But, if you guys have ever seen his explanation when somebody asked him how magnets worked, it is absolutely comical. The guy had no clue, and he tried to bullshit his way through it. And it was just one of the most amazing things I've ever seen. So pretty crazy. So yeah, we do have that static field. It goes up at about 100 volts per meter. It's been measured theoretically up to 50 kilometers, which would give us a 5 million volt difference of potential. Now, the interesting thing about electricity that a lot of people don't know is you can't have an electrical field without polarity to it, right? There has to be something that is, an anode or a cathode or a positive or a negative, but you literally have to have a complete circuit in order for that voltage, for those currents to actually exist. Now, the mainstream will have you believe that, well, this is all taken care of by, Earth's atmosphere, and somehow, this is happening up to 50 kilometers or beyond. But that's just nonsense. That can't work. Electricity doesn't work that way. And it amazes me, honestly, that, you can get PhD, scientists on board with theories like this when they know better, when it violates some of the most basic laws of electric circuit theory. So it's pretty crazy. But anyway, okay, so the next one we got here, and this is kind of cool, is levitating objects using 200,000 volts of electricity. And this is kind of cool. So we're going to cover this one. And here we go.
Wow, 200,000
Of all the
volts.
miracles of science, there's
Yep.
always been one that mystifies and captivates the imagination of pretty much everybody across the globe. It's part of our pop culture. It's tied to divinity, wisdom, and definitely magical happenings, let's be honest. But if used correctly, this miracle is definitely a tool for the future. Hey, it's Jay. Welcome back to a very personal episode of Plasma Channel. I'm passionate about physics and energy for a reason, right? Through electrostatics in particular, you can control the world around you. I've demonstrated that with the firebending and with the waterbending. But the implications of this are huge. Which is why I give you the miracle of electrostatic levitation.
Now, you guys may remember that Zach did a video on this last summer, right? And he was using his electrostatic generator. And we were, of course, demonstrating the role that really we believe is this primary factor in this downward acceleration vector. Okay. I don't, gravity, as far as gravity, whatever they're claiming it is some sort of bendy space-time, which of course we have no example of that, none whatsoever. You can't bend a privation, nor can you manipulate a concept. And that is exactly what relativity does with space-time, right? They can bend a privation of space, right? Something that's not there. How do you bend something that isn't there? And how do you manipulate something that is conceptual, right? And time is conceptual, whether you want to believe that or not. We have our everyday instrumentation of it, clocks and stuff like that, stopwatches, atomic clocks. But again, this is something that arises out of our concept for, to be able to explain things, right? It is definitely a man-made concept. And when they say that you can bend time, or you can change time or accelerate it or decrease it, and then they are crazy enough to actually use a watch, right? Changing time to prove that, that's completely absurd. What does a watch know about the fabric of space-time bending, right? It's just
that's like saying
stupid.
I can time travel by changing my watch.
That's about right. That is absolutely about right. So, all right. So anyway, let's continue on. Sorry about the...
Look, first of all, this phenomenon is flat up mesmerizing. And often small objects can hover perfectly, as if held up by a string. But this isn't about strings or something that you can see. It's about electrostatics. If you'll recall from many past episodes of Plasma Channel, I'm always referring to how positive and negative charges affect one another. It's kind of a common theme / obsession, but levitation of this type relies on just that. When a conductive object is placed between two plates charged to a high voltage, but not in contact, something really interesting happens. With the top plate being charged to negative 10,000 volts, and with the bottom plate at a relative positive voltage, the electrons in the top of the conductive object get repelled down to the bottom of the object. This makes the top of it positively charged. Well then, based off a lot of the other science in my other videos, why doesn't the object just get stuck to the top? Positive and negative are attracted to one another, right? But it's not as simple as that. I'm using foil as the object, and notice the specific shape that I'm using. 2 sharp points on the bottom and a relatively rounded point up top. Now, why does that even matter? Because if the object gets too close to the plate up top, electrons fly off those sharp points on the bottom and it loses charge. Now, this concept of being close but not too close or you lose energy creates a thing called quasi-stable levitation. You'll notice in this video that it's not levitating perfectly still, but bouncing up and down just a small amount. Now, this is an excellent demonstration of Earnshaw's theorem. Earnshaw's theorem dictates that a point charge in a static electric field cannot be perfectly stable, primarily due to the nature of electrostatics alone. Now, for those that think this uses a string or the Earth is flat, here's what happens when you knock it out of the static field.
Wanker.
Or when you use too much power. It just dances on the bottom. For the power source, I used my large voltage multiplier, but you can also use the mini multiplier DIY build of mine, or use a Wimshurst or Van de Graaff. Electrostatic levitation is being used for some pretty cool things, including levitating gyroscopes during space shuttle launches. So I can't wait to see how we use it in the future. I personally find this to be really fascinating stuff. So if you'd like to support Plasma Channel...
Okay. All right.
They can't help themselves, can they?
I know, that was funny, the crack about flat Earth. But you guys notice, of course, that, when he's doing this demonstration, what do we see here? We see 2 plates, right? Here's the Earth, here's the sky, or vice versa, however you want to run it, right? And then the field is actually in between that, right? So, there's obviously it exists on the Earth. So how are they explaining it? Well, again, with a bunch of nonsense. What is that upper plate? And I think we all know the answer to that, because they certainly cannot, say that they can charge nothing. Well, they'll probably try to say they can charge nothing, but the fact is you can't do that. There has to be some sort of physical matter there to take on a charge. And the other thing is he's using a piece of aluminum foil here. Now, the interesting thing about electrostatic charge, unlike electromagnetic or magnetic fields, is that, magnetic fields will have, on some things, magnetic fields will have little to zero effect on it. But electrostatic charge really has an effect on everything. Now, there will be a variance on how much effect they will have on it, due to, their conductivity and their molecular structure and things like that. But the thing is that, I can't think of a single thing that would not be influenced by an electrostatic charge in one form or another. So
it makes me wonder, Bob. He's putting 200,000 volts through this, and like we were saying earlier, the charge from Earth is 50 volts per meter going
100 volts per meter, yeah.
Oh, 100 volts, right?
Yeah.
So even more. So I'm wondering whether you'd be able to see it if you just brought, let's say, this bit of tinfoil up to what would it be, 2,000 meters or so, to get the equivalent of 200,000 volts. I wonder if something happens at that sort of height. I don't know if that makes any sense or not. But
well, I think at that point they would have to, kind of reevaluate exactly what the fall rate is, right? So we're told that gravity is pulling things down at 9.8 meters per second squared, right? And supposedly, it depreciates, it acts in the very same way as electromagnetic fields. In other words, it is compliant to the inverse square law. And if that's true, then that means that it gets a whole lot weaker the higher that it goes. But you know, I'm not so sure I've seen that. Go ahead, Zach.
What he's showing here really isn't like the Earth, though. If I recall correctly, he just said that he has a negative charge hooked up to it. He didn't hook up a positive charge. The positive charge was coming through induction. So that would change everything that the electric field would be doing. It would work a little bit differently.
Yeah, right. He says
I have videos on this as well. Yeah, and the 2 points at the bottom are putting off more charge than the rounded curved edge because they're sharp edges. That's just how electricity works. At a sharp, like if you point your finger out, you'll have more electricity coming out off your finger than if you used, your blunt fist. That's just the way electricity works. So those 2 sharp edges are kind of keeping it up, but it only having 1 charge to it, it's a little bit different than the way that our Earth model works.
Okay, so how did he? Which plate did he charge, Zach? The bottom or the top one?
He said he charged the top one negative, and then in turn, it sent electrons down. He said, which then charged the plate on the bottom to be positive, which is just induction. I mean that does happen.
Well, or
when you do this, if he didn't shape it like that and he allowed it to touch, say, the bottom, what would happen is it would become positively charged and then fly up and touch the negative plate. And then once it became negatively charged enough, which happens very quickly, it'll start bouncing back and forth between the plates. I have some old videos on this that are done with real bad camera work. So I'm going to redo this one because I think this is a good one to, what he's showing here isn't exactly like what we see on Earth, but I think I could actually recreate this.
Well, we can.
Sorry about that.
We can also. You can also say that there is a capacitive coupling going on here as well to that bottom plate. And without giving everybody a lesson in inductive and capacitive coupling, basically, capacitors are, if you had 2 plates and you have a dielectric in between them or something that insulates them and a charge on each plate, and if you connect a battery to each of those plates and then remove it, well, the attraction between the plates will hold the charge on there. That's a capacitive type of effect, right? Whereas an inductive type of coupling is done with the magnetic field. When you have a magnetic field cutting across a conductor, it will start a current flow, an electric current flow. So that's basically how transformers work, stuff like that. And there are other variations of it like that, but there's also other ways that these can be coupled in. So
Does anyone know how he's getting the 200,000 volts? Because he only mentioned 10,000.
He showed it there at the end. He was using, 200,000 static electricity really isn't that much. I can do that with my Van de Graaff generator on a nice dry day.
It all depends on the current, doesn't it? It's the
current and really the amps. That's what really gets you. So what he's doing really isn't. He's just adding the charge to it. And even if he's constantly adding it to it, it's electrostatic. So it's not, building up the charge is going to dissipate off that plate. It's not going to store it in there and explode or anything like that. It's flowing.
There was another guy called George S. Piggott, and he was doing similar experiments using sort of suspended balls and things like that. And the other thing he sort of noticed is that if one of the balls was heated, then it would change its position relative to that electric field. So I found that quite interesting. People can look him up.
Yeah. So What's Up in the chat is asking, how is this dude using 200,000 volts? Well, normally you would think that would be really, really dangerous. And of course, 200,000 volts can be dangerous if there is any amount of current flow that accompanies that static potential. But when you're dealing with things like Van de Graaff generators, what they do is they will they will generate a very high static voltage, but they will not deliver a whole lot of current. And the current is the actual electron flow that goes through it. And of course, it takes two things you have to consider, for total power consumed, power in watts, and that's current and voltage. And so basically, voltage is measured in volts, current is measured in amps, and in order to figure the power, you multiply the voltage times the current, and that gives you your power. But what he's doing is he's using something that is extremely high voltage, but very, very low current. So you really don't have a whole lot of power that's available there to injure you. It's not that you wouldn't feel it, because you would, but it's not that dangerous. So that's why you can get away with using those type of voltages.
And
yeah, I've been shocked by 200,000 volts. I got a video on YouTube of me doing it. It's about between 4 and 4.5 inches of a jump to get 200,000 volts. I think your math is a little off at the 1,000 per centimeter. I think it's closer to 5,000.
What math at 1,000 per centimeter?
He said it's 1,000 volts per centimeter. Electric discharge takes place, and it's 3,000 volts per meter.
Okay, so let's go ahead and finish watching the rest of the video, because we're kind of getting ahead of this guy. So let's just start it back here and let's finish it out.
Positive voltage, the electrons in the top of the conductive object get repelled down to the bottom of the object. This makes the top of it positively charged. Well then, based off a lot of the other science in my other videos, why doesn't the object just get stuck to the top? Positive and negative are attracted to one another, right? But it's not as simple as that. I'm using foil as the object, and notice the specific shape that I'm using. 2 sharp points on the bottom.
Wait a second, we already did finish this, didn't we? I'm just sitting there going, wait a minute, we did this already.
Yeah, we got this one done.
God, jeez, man, sorry about that. Brain cramp. I thought we were on the next video already. Whoa, far out, man. Okay, all right. So let's shine that. So, whoops. So basically, that just gives you an idea, that what's going on to the Earth. And the neat thing about electricity is that it is scalable. So when you can do little electrical experiments, on the level of this, or what Zach does with, his magnetic or electrostatic experiments, they are most definitely scalable, and you can scale them up to Earth size, and bada bing, it still actually works. So it's pretty cool about that. So I guess we've also got this in here. So I think maybe we do. So Lucas, do you want
to play that one? That would be all right. Yeah.
You want to look at this one?
Just
okay.
To go through the galvanic cell. Yeah.
Okay. So let's look at the galvanic cell, and basically this is something that Lucas has come to believe that this is exactly how the Earth is operating. As a galvanic cell type of battery, right? This is what's generating this enormous electrostatic field. And of course, again, when you scale it up to the size of the Earth, you start getting into some fantastic power, ratios, obviously. So let's talk about this.
It's one component. There's sort of, as far as I'm concerned, there's multiple batteries and they're overlaid on each other, so it's just not simply a galvanic cell. There's actually thermogalvanic cell, there's flow batteries, and but we'll get to that a bit later. But yeah, this is the basic principle of how to create electricity. So yep, let's go for it.
Okay, let's watch it.
In this episode, we are going to focus on the electrochemical background of galvanic cells. We are going to discuss what kind of chemical reactions happen in a Daniell cell and what are the basic parts of it. And of course, all of this in under 5 minutes. Galvanic, or voltaic cells are electrochemical devices, which generates electricity from spontaneous oxidation-reduction reactions. So let's talk about the basic structure of a voltaic cell, illustrated by the most common example, which is the Daniell cell. It is composed of 2 half cells, connected by a salt bridge. In the case of metal electrodes, a half cell composed of a solid metal and an electrolyte, which is a sodium filled with the cations of the metal. In this case it is zinc, submerged in zinc sulfate solution, and copper, submerged in copper sulfate solution. As we put these pieces of the galvanic cell together, electrons start flowing from the negative part to the positive, which we call electricity, and can turn on a light bulb, or we can measure it with a voltmeter. Now let's see what is happening in the electrolytes. As zinc atoms lose 2 electrons, they become zinc 2+ ions and dissolve in the water.
Interesting sound effects.
This is the oxidation process, and the half cell where it takes place is the anode. In the other beaker, Cu2+ ions gain the electrons of the zinc and become copper atoms. This half reaction is a reduction reaction, and this half cell is called cathode.
His
as
sound
the
effects
reaction
are
goes
bizarre.
on, the cathode gets bigger and bigger as it gets more copper ions. The anode gets smaller as it loses electrons, and hence atoms as well. So if you watch closely, you can notice that there are positive ions accumulated on the left side and negative ions on the right side. If there were no ion bridge, one half cell would gather the positive ions together, and the other one would gather the...
Oh, who is that? That's one of you guys.
Yeah,
For me, I'm muted. I think it's Zach.
Yeah, well, my headset's muted.
That's so weird because it's producing a really bizarre noise in the background. It's gone now, so let's continue. I was thinking that was in the video. Sorry, guys.
The negative ions, thus preventing further reactions. Fortunately, we do have a salt bridge, which is usually a U-shaped glass tube filled with an electrolyte. This electrolyte can be constructed from several components, but it is always composed of positive and negative ions. In the case of our Daniell cell, it can be composed of potassium and nitrate ions, for example. The positive ions migrate into the solution, where the negative ions are accumulated, and the negative ions migrate into the solution where the positive ions are located.
Interesting.
If you like this video, please
All right. So that was probably a little more chemistry than what you wanted, but that gives you the basic idea of how a galvanic cell works. So now, Lucas, can you kind of take and apply this and talk about what you mean by how you're applying this to the Earth, and how is this working in the Earth model?
Yeah, I can. I can share my screen just to give a bit of a picture.
Okay. So whenever you want to share, go ahead.
You can see that there?
I do. Let me switch over to it. All right. And you are presenting.
Yeah. So basically using that, the model of the galvanic cell, I started applying it to the Earth, and what ended up happening was that the moon became the anode and the sun became the cathode. The electrolyte is the oceans, but it's also sort of, there's an upper electrolyte, and that's just basically from the action of the sun doing something what I call world distillation, where it lifts up all these elements into the higher atmosphere. And then the salt bridge, that connecting piece between the two electrolytes, is the Earth. And so it's just very similar to that. So once there's also another battery that sort of overlays with that one. Let's see if I get a bit struggle with this program. Sorry about that.
No worries.
But it's called a thermogalvanic cell, and that is basically a cell that is has a temperature differential. And so in this case, it's the sun's hot, the moon's cold, and there's a electric current that actually flows from the cold to the hot. And this is the same as in the galvanic cell, where the electric current flows from the anode to the cathode. In this case, it would be from the moon to the sun. And then there is also another battery that seems to overlay, which is called a flow battery, and that's where you have two electrolytic substances of different potentials. So when you apply the chemical interactions, what ends up happening is you end up getting some certain elements that are abundant in our world that could be part of this process, because you need certain elements within the galvanic cell for that chemical reaction to occur. And so when you apply that, you end up with mainly the sodium chloride to the sun side of things, and then the potassium nitrates to the moon. And you can see this sort of diagram that I've done here. And so when you include the sulfur or the sulfuric acid, then you get certain elements like nitric acid and hydrochloric acid. And so they are sort of chemicals that can actually, are involved in that electrochemical operation. And so when you have nitrates as well, you're also sort of dealing with endothermic reactions, which is getting their heat using chemical reactions, so it actually gets colder. And then on the sun side, it would be exothermic. So we really see this type of polarity that occurs between the sun and the moon. So sort of any questions in regard to that?
No, it makes perfect sense to me, but sorry, Bob.
Oh, no problem. I'm just curious about, you're using the Earth kind of as a neutral, and the sun and the moon is the cathode and the anode of this type of circuit. But I'm just wondering, in your model, are you making an allowance for the firmament playing any active role in the electricity or not?
Yeah, well, I've put forward that it's the firmament is a creation based off temperature differential. So when your gases get really cold, and I've also done a video showing that it could be like a solid oxygen. Now, when you get a temperature differential, it basically cools it down to such a state that it turns into this crystalline structure. And so when you have air movement or anything like that over a solid surface like that, well, you're going to get basically a buildup of static electricity. And so there's other properties in regards to this solid oxygen, or whether it's solid oxygen or nitrogen or one of those lighter gases that are start to condense and turn into a solid form, a crystalline form. Then you get stuff that occurs like superconductivity as well. So it does play a huge role in basically supporting how much electrostatics are higher up you go, sort of thing.
Oh, okay. So,
this.
Oh, no, go ahead, John.
I was just saying there's a sort of urban myth about, I think they call it sky glass, or do you remember that, Lucas?
Sky eyes. Yeah,
sky
there were
eyes.
a few comments.
Well, there's the sky glass that they find in the desert.
The Libyan desert glass.
Yeah, but this is stuff that people have theorized. Well, they've said that they're working on in Antarctica. And it's blue.
They can't bring it back. It disintegrates even if they keep it at really cold temperatures.
That's right.
It just evaporates into air. It won't even turn into a liquid.
And do you remember that guy John Brahma who claimed he was on some Antarctic force, protection force or whatever, and he sent us a picture of a wall of sky ice or sky glass or whatever it was, and we did a bit of digging into it, and it was taken by a member of the Rothschild family. Do you remember that? She was a photographer.
That figures. Disinformation. Okay. Yeah, that's interesting. You know, because a lot of people also have made the assumption that it could also be sulfur hexafluoride or SF6 that is up there. Iru has talked about that quite a bit, and I think Robert Bassano is also kind of on board with that. But this is where, you know, I get a little bit weak on the chemistry side of it, so I'm not exactly sure, you know, how that would work, other than it has some very interesting characteristics when it gets to very close to absolute zero. So, and, you know, we can assume that, you know, up there at 62 miles, if this is where the firmament actually is, then it would be pretty darn cold up there. And it's interesting because when you launch a balloon, and we've launched a couple of balloons, of course, everybody's putting temperature sensors on them too. And even the Go Fast rocket had a temperature sensor on it. And even though they said it went up to around 70 miles, something like that, it was showing a temperature that was pretty close to absolute zero, which to me, that's crazy, but you know, that's what it was showing. And that's really the only other indication we have of that. So.
And sulfur does play a major role in that galvanic cell type of idea as well. It's basically, you need it as a reactant. It's the acidity that, you know, breaks down these metals to create that ionic flow.
Now, so before we get into the sulfur too quick, Lucas, I just had one quick question about the sun and moon and the so they say we have these things called the solar winds or the coronal winds, and they say, you know, they come from space. But do you think that that could be the interaction between the sun and the moon, and where these wind paths high up above in the altitude are actually traveling? Could it be the ionic wind from our positive and negative and the interaction between them?
Yeah, I think there is a definitely an interaction, and I've sort of described it similar to vacuum tubes, where there's or a low pressure tube like a vacuum tube, where there is a correspondence between the anode and cathode, and there's a transference of energy, but you may not see that energy, but it's there. So that's like something practical that I've seen that is could represent what's going on. And as for the sun, well, it's basically, you know, I regard it as a plasma around a sort of metallic object. So the reason I say metals, as we showed before, there was the electrostatics where you could lift the metals. And you really can't create a battery without these two different types of metals interacting. They need to be, unless it's the thermogalvanic, but since we've got the galvanic and the thermogalvanic happening, there needs to be a dissimilar metal. And that's why I sort of say the planets are metals to actually have this reaction happening. And I can go into how they may get there and the use of electrolysis if you want. But yeah, I definitely think there's an outflow of energy from the sun, from the plasmas that's being created.
Right. Well, that would, you know, obviously, in order to have interaction with the things like Mars or the planets or anything like that, then you have to start considering, you know, what is up there on the other side of the firmament. Is it a liquid type of thing, or, you know, is it a gas continuously, or, you know, what would be conducive to that? And then ultimately you have to kind of expand out to the whole, you know, stellar network, right? All these stars, which, you know, people have generated, you know, the science of astrology. And I know people say, it's not a science, but, you know, it's a lot more science than astronomy is, for, you know, by a long shot. Because it deals specifically with the energetics that are developed by the star configurations as well as the planet configurations. So it somehow, you know, it appears to be, setting up this grid of energies that have very profound effects. And, like I said, whether you want to believe in it or not, what's the old saying? Millionaires don't use astrologers, but billionaires do. And, if people really did some research into that, they would find that when astrology is done right, it can be amazingly accurate at what it predicts. So, but again, and that would just...
what I've found with the astrology type thing, and you apply it with, say, some of the ideas of sound and how these waves interact, well, then you start using it as an energetic calculator, where sort of you can see where planets are opposed to each other. You get, say, destructive interference, these interference patterns, as well as when the planets are conjunct, you'll get constructive interference, which is they're in phase. And so there's something very interesting about using it as a calculator for the, sky energetics, in a sense.
Interesting. Yeah, and that makes sense. I'm sorry, go ahead.
Lucas, is there much... is there some correlation between the planets being at 90 degrees as well? Because it just makes me think of, an electric and magnetic circuit and gyroscopes being offset by 90 degrees and that sort of thing. Is there a 90-degree correlation as well?
Yeah, well, when you get squaring and things like that, you're basically looking at two different sine waves and how they interact and whether they're going to cancel each other out or increase each other's energies. So, yeah, it's only something I've briefly sort of started to put together. It's not something that I've really delved super deep into.
Yeah, something that
if you look at the...
Go ahead, Zach.
I was just going to say, if you look at the right-hand rule of electricity and magnetism,
that's what I was talking about. Yeah,
our Earth is set up. We have a South Pole magnet at the center. We call it the North Pole, but it's actually, it acts like a south end of a magnet. Well, that would mean that your thumb would be pointed down, and that's your electric flow, and then your right-hand rule. So your fingers are arcing east to west. If you were looking at the AE map, that's the way things would be moving. So it kind of makes sense that if they're moving with the magnetic field, the planets, they would be moving from east to west in the motion that they're moving.
Interesting.
Yes,
it's just something a little bit interesting about when you apply the battery and you say, well, usually when you've got a battery, you're deriving energy out of it to, start your car or, charge your phone or whatever it is. So it's the actual appliance that's using the energy. Well, when you actually overlay it onto the world, the appliance part of it is the sun itself. So the energy generated is part of the sun. And then the sun's energy itself is the thing that actually keeps the winds going, lifting up all the electrolytes out of the oceans and keeps the whole cycle running. So that's just an interesting point. And because I treat the world as a closed system, the energy really just cycles rather than, getting dissipated out somewhere. And so you end up with two effects. You end up with, the galvanic battery type thing, but you also end up with electrolysis occurring at the same time. And so with electrolysis, you can, there's lots of fascinating things involved in that subject.
Yeah, it's like a battery without, any nubs to hook up to. All the stuff just stays in there. There is no opening to let the electricity out, the energy out.
Yeah, absolutely. I think one thing that would really help a lot of people in the audience, and so guys in the audience, let me know if you would be interested in us doing this. But in order to understand, the role that electricity and magnetism are playing, especially as we kind of lay it out for a flat Earth model, and we, first of all, I have to say that what we're proposing today is, obviously we don't know if it's right or wrong or otherwise, but it seems to me that if you guys had a little bit more knowledge about, some basic electrical and, type of circuits, that would help a lot in understanding, and also the roles of, how magnetics play in inductance and capacitance play in electrostatic type of fields. Would that be something that any of you would be interested in, is just hearing us talk a little bit about, some basic electrical circuits type of things? Or is that a little too dry?
Sounds good to me.
Yeah. Well, it just gives me something to, that I can put together, maybe a small segment or something like that. But
yeah, I'm sure we could make it fun. We could make it fun.
We'll try and make it fun. But because it really does help a lot. Otherwise, because I don't want to be sitting here talking about things and when something is completely going over your head and you're just like, yeah, I really want to understand this, because I know that, most flat earthers are like we are, we really want to understand what the heck is going on here. And, unfortunately, unless you have been, in, higher education or something like that, or just a nerd in general, you're probably not going to be too familiar with that. But, the things that are going on here, especially when, we're talking about how they actually, are playing a role in, the very environment that we're in, I think it's interesting as all get out, right? So I think a lot of people would be interested in that. And it sounds like, I'm watching the chat, and it sounds like everybody would be pretty interested in that. So
it's a resounding yes.
It's not only that. It's when you're looking at electrochemistry, you're also looking at, say, components of the body, say, how your nervous system works, or intercellular sort of mechanics. So it doesn't just apply to, say, this macroscopic view of the world, but it also applies to, how plants function, all these different things. So it really is a sort of science that covers, nearly everything as far as I've been able to see.
Yeah.
Yeah, and if they don't teach it at school, or if they do, they make it incredibly complicated, then that's got to speak volumes too. It's definitely worth explaining this part of it, so we're all a little more on the same page, I'd say.
Yeah, Teddy.
If you want to know what electricity does, go watch the first 5 minutes of Walter Lewin's 802 Electricity and Magnetism course. He was a MIT physics professor for 4 decades.
Well, watch the entire course.
Yeah, exactly.
A lot of it is.
People pay thousands for that, don't they?
Yeah, it's a $27,000 education for free. And that was over a decade ago, so it's probably way more than that now, the way things are going. But he tells you flat off, this place wouldn't exist. You wouldn't see, you couldn't hear, you wouldn't, think. Horses couldn't run, hearts wouldn't beat. The sky wouldn't be blue, rainbows wouldn't happen.
Was it
all
you,
this
Zach?
Trains, planes, cars, everything is electricity. Everything.
Was it you that put the question out, Zach? You were asking us, or everyone, can you name a process that doesn't involve electricity, or was that you, Lucas?
Yeah, I did that. It's like, yeah, that's right. Can you create light or any of these things without, these electrochemical processes? And really it comes down to, it's like the foundation of how electricity is created. And so if we're saying that we're in an electric environment, then basically what I'm trying to look at is, well, how is that electric environment generated? And it really just leads back to these battery ideas, and how they actually overlay. It's really interesting. Before I get too far ahead, I just, with the planetary metals type things, it's just how that can be created. I've got it up here. It's just via Mercury. And if anyone's done any sort of looking at the element mercury, it's really interesting on how it amalgamates other metals or draws metals into themselves. And then you also have the process of electrolysis at play. But, a lot of this is actually due to how the role of volcanoes in our world, in that they push up a lot of mercury and sulfur and other elements right up into the high atmosphere. So that was I thought I'd quickly add that because I think it's a pretty important sort of piece to the puzzle.
Good to play that video of the mercury eating the gold leaf. That's always.
Yeah, I can get out of this.
That's pretty crazy. Okay.
Well, it is, and that's what you're talking about, isn't it, Lucas? Is that the mercury in the atmosphere could amalgamate all these distilled, am I getting that right? Distilled metals up into that are in the atmosphere, the higher atmosphere.
Yeah, well, once it
something like a planet.
Yeah, well, once it's up there, it has all these qualities like high surface tension. It does some really interesting stuff when it's in an electric field. It's almost like it's got a mind of its own. And so just really that high surface tension, and then it's able to accumulate elements within itself. And then the refining process, which we use for metals anyway, to refine metals out, is through electrolysis. And so as soon as you've got a high current or a high the amount of electricity in the atmosphere, you're going to get these electrolysis properties happening, and so a refinement.
Very interesting. Okay. Somebody had a comment earlier wanting us to explain the 3, 6, and 9 in how it applies that 3, 6, 9 mathematics, the vortex-based mathematics. And interestingly enough, this is something that is not generally known in most electronic circles. This is something that's fairly new, but the 3, 6, 9 mathematics, and also the way of winding these coils, which are called Rodin coils, are considerably more efficient, and they provide some very interesting effects. So yeah, that's something that I would love to cover. I'll absolutely throw that kind of stuff in, because again, the stuff that they show us, most of it is very mundane, but some of the stuff like Randy, oh God, I forgot Randy's last name, but he was Marco Rodin's research assistant, Randy Powell, that was his name, Randy Powell. We had him on a Globebuster show, and he did a TED presentation that was absolutely phenomenal, where he was causing things to happen at a distance, spooky action at a distance using these Rodin coils. So they're pretty cool, the things that you can do with them. So we'll try and include that in there as well. So anyway, what else did you want to show us, Lucas? I'm sorry.
I can show you more things. Well, that was basically it. It's just basically an overview. If you want me to keep going, I can.
Okay.
You have the video with the orb inside the metal induction coil, or the induction coil, where it starts it's levitating and it starts glowing like the sun. How this metal orb can look like a sun.
That's very cool.
Is it this one? Oh, wait a minute. You guys aren't seeing it. Is it the one that's in the copper coil? That's the metal with magnets?
Yeah.
Yeah, I think that's it.
Yeah, I have that pulled up. Let me switch you guys over to it. Okay, you guys should be able to see that, yes?
Yep.
Yep. Yeah, when I think of the planets the way Lucas is describing it, this is how I see it.
Yeah, that's interesting the way these things are. It melts it and makes it red hot. Pretty cool.
Yeah, so what I have thought as well is that the moon is more of a high voltage sort of situation, and it has ionic winds, whereas the sun is more of a high current situation where it's generating that heat. and then you've got the surface plasmas. But this is a levitation via high current.
And what's he levitating? Was it a magnet? Is it
I think it's
ferrous?
just a piece of metal.
Yeah, it's just a metal. And, it's interesting because there are some videos out there that are very interesting that have shown areas that were like getting hit by severe lightning storms and really super high electricity. It would cause things inside of these buildings to actually start levitating. And these are like transmitter shacks that are up on mountaintops. And it was crazy seeing that stuff. It's like, high voltage electricity can do some really, really crazy things.
Wow.
The other thing with the galvanic cell is that on one side of the galvanic cell, which you're looking at, the anode side of things, is more oxygen based. So it sort of relates to this idea of air. And then on the cathode side of things, you're looking at more hydrogen based, where hydrogen is created. So you're getting this sort of polarity in those two different things. But and that's why I sort of tend towards this, that there's a burning hydrogen, burning sulfur, exothermic type ideas in relation to the sun.
And something interesting about that, you found an article or a study that was showing the moon emanating oxygen. You remember that?
Yeah, well, there's actually lots of different things, relating to the moon, sort of acting with the sodium, so acting more like a sodium lamp, and then there's oxygen being created. Yep. So the other one with the sulfur, which you're probably going to show this video here, is that when sulfur is in its plasma state, it actually creates the same spectrum as sunlight. So I found that was an interesting sort of part of it as well. And so the hydrogen's going. Oh, sorry.
Sorry, go ahead. Go ahead, Lucas. Okay.
Well, the hydrogen is.
Man, Skype sucks.
Yeah.
Go ahead, Lucas.
All right. So the hydrogen would be more in that infrared spectrum as well. So, and that's why when they're looking at, say, the sun through a hydrogen filter, you're gonna get a correspondence there. So that was all I was going to say.
Okay, cool. Now, what were you going to say, Zach?
Yeah. The sulfur actually creates a very high magnetic field when it's fluoresced. So much so that they invented these sulfur lights, I believe it was back in the 90s, early 90s. And they had to put shielding over all of these things because it was messing with certain radio wavelengths. The satellite radios, XM radio and stuff like that, were complaining that these lights were interfering with the signal getting to their customers. But it creates, just like the sun, a very high electromagnetic field.
Yeah, wide spectrum.
Another interesting thing is once it gets going and you actually power it up to where it's illuminated like that, you can turn the energy down that it took to do that to only 10% of what it took to ignite it, and it'll keep it running. So it's a very efficient way to light things. It takes a little bit to get them going, but once they get going, you can turn that electricity turns way down the input needed to keep it going.
Yep, very cool. Okay.
Yeah, everything about this system when the batteries seem to overlay like they do is just increasing efficiency. So it's just super efficient. Plus the energy seems to be circulating around like a closed system, and so you're getting all these end products like transmutation of elements and things like that as well. So yeah, the efficiency is just incredible.
And that makes perfect sense, doesn't it? I mean, you wouldn't just use one energy creating thing like a galvanic cell. You'd use all energy creating things like the flow battery and the Thermogalvanic Cell, and probably numerous other methods of creating energy and that we don't even know about yet.
Well, yeah, well, that's right. Even when you look at the salt bridge, which would be our Earth, you've got aquifers running through there, which is the transference of electrolytes into the oceans as well, and you're looking at more nitrate sort of there. But you've also got the molten salt, what you would call molten salt, and this is a type of battery as well. And you can see a correspondence between that and lava. So this idea of electrically charged lava, basically, and that holds huge amounts, and it actually acts as a capacitor in a sense to the whole system. So just some very extra little information there. So
yep, beautiful. Okay. All right. Well, I think we can probably wind down on that, because I don't want to stick on any one-two subject, too long, so we don't lose anybody's attention or anything. But I do want to jump over to one other thing that we'll probably be starting to cover next week. And this is something that I found this week that I thought was really cool. And let me actually bring that back up again. Where did it go? There we go. Okay. So I was telling you guys earlier about, this guy that I found recently this week, this Ronaldinho, if I'm pronouncing that right, but he is kind of like Ken Wheeler, except he's a little bit easier to understand. And he is writing papers with this Lori Gardy, who is Fractal Woman, and I've talked about her before several times. But one of the things that they are working together on is this magnetism and ether, and how magnetism actually works. So what I want to do is I want to share this video, and we're going to kind of go through it a little bit. But this video, it starts out, I'm not going to play the first part of it, but it starts out kind of funny because it's talking about Richard Feynman, right? And Richard Feynman gets asked about, what is magnetism? What's actually causing it? What causes attraction? What causes repulsion? And he absolutely tries to skate around the issue, and he starts changing the subject to absurd things, to, why old ladies fall down on the sidewalk and just ridiculous stuff like that. So it's pretty funny, but it just, Ken Wheeler talked about this too also. But it's just funny that, he's supposed to be one of the one of the icons in science, basically, and has all the answers. And, he's basically saying, well, I could explain it to you, but you'd never really understand it. And
but I'd have to kill you.
Yeah, exactly.
sounds like deGrasse trying to explain gravity.
Yeah.
Don't ask.
Yeah, don't ask. But of course, like Albert Einstein said, probably one of the only coherent things he said was, if you can't explain it to a 6-year-old, you don't understand it yourself. Okay. And I agree with that. And that's one of the things that, we've always tried to do on Globebusters is when, something comes up, whether NASA's doing something or people are trying to understand why they think they see the ISS, but they can't possibly be seeing the ISS, and it's something else. We try and simplify that by, getting down to the basics as to why. For example, you cannot see something the angular size of the ISS. The fact that it's supposedly reflecting a light, which would be impossible, for the angle that it has on the sun, and the fact that it would keep meeting your eye as it travels 2,600 miles across the country. Those are the kind of things that we really try to simplify here. And so I really appreciate it when people, explain things in terms that a 6-year-old, literally, or a child could understand. It's really cool. So what she does here is she is going to give an explanation about how magnetics work. And she gets a little bit into fluid dynamics, because one thing you need to understand about the luminiferous ether is it behaves very much like a fluid. In fact, and so the fluid dynamic laws, really seem to work for it. And when I used to teach electronics, many years ago, I would use a lot of analogies with water to teach electrical circuits because it really makes it understandable. Most people have played with a hose, and so they understand changing the pressure or kinking the hose for resistance. And, you can just make all these really neat analogies using fluid dynamics to understanding things like magnetic fields and the luminiferous ether and things like that. So
and that picture back then, that whirlpool picture, is exactly how I've seen the ether. If we ever were able to map it out, and hopefully we would at some point, that's exactly what I think you'd see, is that spiral whirlpool thing over a flat plane.
Absolutely. In fact, there was a really cool video put up by this girl called Physics Girl, and she did this thing where she ran a plate in a swimming pool and just kind of pushed it. And what it did is it created a vortex. It created dual vortexes that were connected underneath by an underwater vortex. And then she put some food coloring in it and watched it track across the swimming pool.
Oh, wow.
And that was, in fact, I may be able to play that for you here in a little bit, but it's just really cool when you can get a visualization for those type of explanations. And I just, I really, really appreciate that. So what I want to do is I want to play this for you guys, because this is really super important. When you understand a little bit more about how magnetism works and how the ether creates it, or as I should say, it's actually a different modality of the ether, as is electricity itself, as is dielectricity. Once we get those three principles down, I think, we've got a really good solid understanding onto how a lot of things work in our flat Earth. So what I'm going to do is I'm going to start this. Let's see. I'm going to start this right back here, and we're going to go through it. And I think you guys will probably enjoy this as much as I do, because it really is super interesting. So here we go.
Okay, that is a very good question. I know that children love to play with magnets, and I'm sure.
So basically, she's saying that this is a child that's asking her how a magnet works. And the volume's a little low, so that's why I've got the CC annotations on.
So I'm going to try and answer that question, and I'm going to try and answer it in terms that you can understand. So first, I'm going to give you a bit of a clue. It has to do with water. Now, everyone has personal experience with water. Children play in the bathtub. They know about water. Everyone has seen water go down a drain. Everyone knows that water likes to spin. Anyone that has been near a lake or an ocean knows that water forms waves. And so this is all, so if you understand water, if you have personal experience with water, you can totally understand why magnets attract and why magnets repel. So I'm going to start with this experiment. This experiment was done by an independent researcher, Lionel Deneuve, which I have been researching for many years. So in this experiment, what he did was he took two cylinders and attached them to motors, which are up here, and he placed them in a pool of water, and he's spinning them. Now in this experiment, the two motors are spinning the cylinders in opposite directions. Now it's going to be hard to see in the video, but they are spinning in opposite directions.
Okay, so the thing you need to understand about this, guys, is that the water is representative of the luminiferous ether, or this background fiber, or this background material that all things manifest from. It is the material that propagates light. When it is stimulated, light actually is induced into it, and it propagates across the luminiferous ether. So if you consider the ether as kind of like this water here, right? And it behaves very much like water does, and the magnetic field is thus manifested out of it by changing rotations, right? So what she's doing here, or what he's doing here, is first he's going to emulate the spin direction, which would be analogous to the magnet's polarity, going in different directions. All right. And what you're going to see is that the spin directions of these drills or whatever they are, where he's manipulating the water, it actually causes it to act just like a magnet in repulsion and attraction, and exactly what's going on with the fields around the magnets. And we can see this, by the way, with the ferrocell. So this is super interesting. So let me continue on here.
So they're spinning and spinning up the water. And now they are attracting to each other and sticking to each other. And now he's pulling them apart. Okay, they come apart. But then they quickly come back together and they stick together. They attract to each other and they stick together. Just like two magnets that are side by side. Okay, just like two magnets that are side by side attract each other. Now, the idea here is that the two magnets spinning in opposite direction, or the two cylinders spinning in opposite directions, are analogous to a north and a south and a north beside each other. Now, when the cylinder spinning counterclockwise, north would be up, and the cylinder spinning clockwise is analogous to south being up. And I'll explain that again in a minute. So let's watch this again. Okay, so he turned the motors off and now they're just hanging there. So he's going to spin them opposite again. Okay, oh, now they're stuck together. They're sticking to each other just like magnets.
So what's happening here is when the little discs at the end are spinning in opposite directions, it is creating a low pressure zone in between the two discs that are spinning. Now remember, Ken Wheeler talked about everything in the universe is about pressure mediation, right? And he's right.
This
it really
is so
is.
intuitive. This is, to me, this is, if someone said, if I span two things in opposite directions, what do you think would happen? And this is so intuitive. It's brilliant.
Yeah, it really is cool. I mean, because this is a really simple analogous way to look at it. You know, the water is the ether and the perturbations, you know, the two drill or whatever they are, and the two motors running the disc down is the perturbations. And essentially, you know, to make an analog to that, when you make a magnet, you take a piece of metal or magnetite or something like that, you run a current through it. And what it does is it aligns, it changes the molecular alignment internally, okay, of these things. And what it does then is it makes it conducive to providing a resonant path for the ether to travel through, right? It becomes magnetic, right? So that's what's going on when you do that. And then when the ether, which is all around us, you know, you interact with the magnets, you know, with the ether, you can see the pressure mediation then actually, you know, come to life by the difference in rotation or the spin, causing low pressure or high pressure zones. When it's a low pressure zone, they will be attracted together. When it's high pressure, they will be repulsed apart. It's very, very simple like that. So let's continue on. Oh, unless you had something to say?
I was just going to say, if you think of a bar magnet with the north and south pole, like she's got there up in the top right, and the magnetic field that comes off that bar magnet, it comes off at the top. It would go clockwise to the right and down, and it would go anti-clockwise to the left and down. And is that something that's similar to this, or?
Yeah, in fact, they're doing this analogous to the right-hand rule, and the right-hand rule, of course, is when your fingers on your right hand are in the spin direction, then your thumb is actually pointing at the North Pole.
Yeah,
okay?
Perpendicular. Yeah.
Yeah, same thing. So that's how this is working. It's really, really cool. This
Really
makes
cool,
it so simple to understand. So let's continue on.
So in this experiment, instead of spinning the cylinders in opposite directions, he's spinning the cylinders in the same direction. So let's have a look at that. So they're both, it looks like they're both spinning clockwise. And now they seem to be repelling each other. The distance between the cylinders is increasing. So he's trying to push them together, but they're not coming together. You can't make them stick together. See, as he pushes one, the other one pushes away. This is exactly analogous to repulsion of two magnets. Okay, so if both cylinders are spinning clockwise, this is analogous to two magnets side by side, where south is up and north is down for both magnets. Now, if you put...
Did you want to say something, John?
Only very cool. Sorry.
Oh, okay, no problem. Let's continue on.
Two magnets together with south up and north down next to each other, you will find that the magnets repel each other. So this water analogy is quite good at replicating the behaviors of magnetism, of attraction and repulsion of two magnets. So I'm going to show you another experiment using spinning cylinders that Janel did. This time he has a slightly different setup, and what I want to show you is the north-south analogy. So what he's showing here is, here's a cylinder, which you can see sideways here. So this time he's spinning the cylinders horizontal instead of vertical, and he's showing right here that if you curl your hand, whatever direction your fingers curl in, that is the way the motor is spinning. So if the rotor, the spinning cylinder, is spinning in the direction of your curled fingers of your right hand, then your thumb is going to point to the North Pole, okay, of the magnet. It's going to point to north of the magnet. Okay, so he shows two views of it here. And so in this experiment, okay, then he's showing it again here. So in this experiment, the light one is the North Pole and the dark one is the South Pole. So he's always going to spin it in such a way that this is north and this is south. So let's see what else is in here. Okay, and so this is, he's showing a picture of it here. The top, he calls it the top, but the left of the rotor is the North Pole of a magnet, is analogous to the North Pole of a magnet, and the darker yellow here is the South Pole of a magnet, or analogous to the South Pole of a magnet. So I'm going to show you a couple of experiments where he uses this setup. So here he's saying that the two rotators, so he's going to have two of these in his experiment, the two rotators produce water vortices. Now what are water vortices? Water vortices are just spinning water. So when you spin water, it's called a water vortex. There are many ways to spin water. When water goes down the drain, it forms a vortex. There are many other ways you can make water vortices. So when you spin cylinders underwater, you're creating water vortices, and that is that creates a pressure difference between the magnets, between the cylinders, the pseudo magnets, I guess you could call them, and you will see that they attract and repel depending on how you place these rotational cylinders. So let me skip to the experiment. Okay, so here in this experiment, he's spinning The two rotators, the two cylinders, they produce vortices in water, and these vortices cause the cylinders to spin relative to each other, similar to what happens between two magnets. So when you hang two magnets from a string and place them near each other, they kind of spin around and they're attracting and repelling, just like these two cylinders. So this analogy is quite good.
That is absolutely extraordinary, what she just showed, because literally we are creating low and high pressure zones by the spin of these objects on the top, which is exactly what the magnets are doing with the luminiferous ether. So again, a brilliant demonstration of this.
So in this experiment, he rotates the cylinders and places them right next to each other in this configuration, which is analogous to the south-north configuration of a magnet. And you can see that the two cylinders are sticking together, just like the north sticks to south. The light one here, this is north. The dark one here, this is south. And you can see, let's watch that again, that the two rotators are sticking together just like the magnets are sticking together.
Right. So what's happening here is the magnets, of course, each of them has a toroidal field coming off of them, north-south, right? And there is the outer shell of the magnetic field, which is called the centrifugal lines of force, okay? And then there's the inner lines of force called the centripetal lines of force. And basically what's happening is by spinning these like this, when you get the north-south configuration, you're basically matching up the centrifugal and centripetal lines of force or pressure zones to where they match and attract each other, right? And then when you put them together, it becomes like one giant magnet. I mean, it works exactly the same way. It's absolutely incredible.
Yeah, this is
So
just
in
brilliant.
this experiment, he's spinning
This
the two
demonstration.
It really is. It's just fabulous.
placing them head to head, but spinning them in opposite directions. And this is analogous to placing the two north poles together, and the light part here is analogous to the two north poles. So let's have a look at this and see what happens. Okay, so he is placing them together, and then in the case of the real magnet, they fly apart and then they end up, let's watch this again.
Pressure mediation. Ken Wheeler had it dead right, because that is exactly what's happening here, folks.
And then when he lets go of the magnets, they come together in this configuration. Okay, we can kind of do it in slow motion here. Okay, see what the magnets do. Okay, these cylinders, rotating cylinders, are doing exactly the same thing. They are now in the side-by-side configuration, spinning in opposite directions, and they are now attracted to each other. So it seems
Are they
that,
rotating magnets or
is
just
quite good
metal cylinders?
They're just cylinders. They're just cylinders that are, the friction of them is causing a vortex of water, which is then mediating a pressure zone.
Pressure differential between
Yep.
them, yeah.
And I'll be damned if it doesn't work exactly the same way. So that's, and when you really start thinking about magnetism and electricity, and we're going to take this forward, guys, in the next show, we're going to take this forward into how this then mediates out into electricity and dielectricity, and yes, even gravity. You're going to be blown away by this, because this explanation, at least in my head, opened so many doors. It just made it all crystal clear. I mean, talk about lights going on. When I saw this, it's like, oh my God, it's so simple. Ken Wheeler was right, man. It is. It really, really is simple. But
if only Ken Wheeler could explain it like this.
I know. Well, see, I've been saying that about Lori Gardy for a long time. Fractal Woman is, she's able to translate, Ken Wheelerese and put it into English, right?
Glad someone can.
Yeah, exactly.
Yeah, that's a gift. That is a gift.
That is a gift, and that gift now she has given it to us. And I feel like I can explain this very easily to somebody, because it makes so much sense. And you've got the direct analogs, and like I said, guys, wait till I take this into the realm of electricity, and how these interactions happen. With capacitive coupling and inductive coupling. And guys, I will tell you this right now: you will never, ever see this taught in a university. Why? Because they are clueless and they just don't know any better. It's as simple as that.
Is she a flat earther? Do you know?
I doubt it. No, I don't think she is at all, but she's somebody who is seeking truth. And you know what? I think that everybody seems to kind of come to flat earth in their own way. And when I say that, I've told the story many times about how I got into flat earth was reading a forum called Clues Forum, right? And, Clues Forum went on, they had great sections on debunking NASA, debunking rockets working in space and in vacuums, and, the ISS debunking that, all kinds of things. But for whatever reason, they seem to think that NASA was putting on a psyop with flat earth to try and lead everybody off the trail. So they thought that flat earth was some sort of a psyop that NASA was putting on. And of course, that doesn't even make any sense to me. But what the really interesting thing about it is if you go and you read the NASA DBA flat earth psyop thread on there, ultimately it kind of petered out about a year ago because everybody appears like they no longer believe in the heliocentric model. Some of them believe in the flat earth, and some of them have created their own models, like Simon Shack, right? So you got to love it. Absolutely got to love it. So when you are truly investigating and you are truly intelligent, like these people are, even if you think that flat earth is a hoax, I mean, if you are honest with yourself and honest with your research, you will come to flat earth. You will see it. I mean, we all did, didn't we?
Yeah, she is definitely a truth seeker. She's the one who pointed out to me in one of her videos that the ionosphere is impossible.
What, she commented?
No, she did a half-hour video.
Oh, wow. Right.
A paper written by a physicist back in 2012. One of only 3 published, and it was published in a journal. I mean, he's a very well-respected physicist. But one of 3 papers over 100 years, they were pointing out that Maxwell's equations are wrong. That, equation number 1 and equation number 4 don't mesh. It says 2 totally different things in there. So, yeah, and I asked her bluntly, I was like, so does this mean that the ionosphere, the way they say it works, is impossible? She's like, absolutely. It's like, do you mind if then I put the video on my channel and said it was a mirror from her. But, yeah, it's on my channel. She, pointed that out to me. So she's definitely in it for the truth. She's not pushing a globe agenda or any type of agenda. She seems very legitimate, just sincere and wanting to know what's going on.
Be interesting to talk to her, wouldn't
it? Yeah, she would be. But like I said, she's not a flat earther, and she may not even be receptive to the idea yet. But like I said, as I watched everybody on Clues Forum, it was amazing to watch the transformation as they viewed the evidence and presented it to each other in their very methodical, scientific way, to watch them all eventually completely lose faith in the heliocentric model and either wind up believing in flat earth or like I said, in the case of Simon Shack, he introduced his own model. and it involved the sun going around the earth, right? So, which is quite a start. It's very interesting, how these people do this. And, Simon Shack and Hoi Polloi and those guys, they are super intelligent people.
I'm waiting for the Electric Universe guys to cotton on as well. That will be a momentous occasion.
Yeah,
I'm sure half of them have, to be honest.
I do too, and I think a lot of these guys do. But of course, they can't say anything because the second they do, they've lost all credibility. Oh my God, you're a flat earther. We can't believe anything that you've said. And you know what? I get that.
They actually have their foot in the door. They're making waves with their ideas and what they're showing and presenting. on a very large scale. So yeah, I understand why they don't want to come out and say, "Hey, I think these flat earthers are onto something." I could
Takes
see why
courage,
they
though,
would do
doesn't it?
that. Yeah, it does. It really does.
That's right. So you know what? I'm okay with being the huckleberry. You know what? I'm okay with being the whipping boy on this. I will come out and I will say it. You know where they're going, I will say it. And you can call me a jerk, an idiot, a moron, whatever. But you know, I know that what I'm putting forward is very viable. It's likely true. And I honestly believe that eventually these guys are going to come to understand this, and at least somebody has kind of broken that pathway, right?
Yeah.
And you know, I'm happy to do it. I really am.
No, I'm with you, Bob. I was a big proponent of Electric Universe prior to this with Jim McCanney and all the rest of it, Talbot. But yeah, sometimes you've just got to grow the kahunas and say the truth and say what you're seeing.
Exactly. And you know what? You know, I've been doing this for 6 years now. I've heard every insult there is, and they honestly don't bother me anymore. 15 degrees per hour doesn't faze me because I know these guys have no clue. I know they're desperate and they have absolutely no concept of what they're even talking about. You know, they're just parroting something. Oh, 15 degrees per hour.
Cheers, Bob.
So it's pretty awesome. So, okay, guys. So what I want to do now is I want to close down the YouTube stream. So I'm going to paste the Rockfin. Let me do this. The Rockfin link or the DLive link, either one, in the YouTube chat. So, and mods, if you would kind of spam that. There's the Rockfin one. And here comes the DLive one. And we're going to let those run. And then I'm going to shut down the YouTube because what I want to tell you guys about, I cannot talk about on YouTube because they will strike me sure as anything.
Yeah,
so
screw YouTube.
Yeah, so screw YouTube. We're going to go where we can talk freely. Like I said, you can go to either Rockfin or DLive. And here this Rockfin is set for a free presentation, so you don't have to be a member to go there. And, you know, we're going to be good to go. So with that, I am going to...
Carmen to say that. They need Carmen to do that. Screw YouTube. I'm going to Rockfin.
That's right. Screw you, YouTube.
I think you just done it, Zach.
Yep. So I'm ending YouTube now, and we will see you guys in a minute over at Rockfin and DLive.
Sweet.
All right. YouTube is now